decades of atmospheric testing, lofted micron-sized plutonium oxides. Prevailing winds deposit them in a narrow belt where crops fail despite adequate rainfall. On the northeastern steppe of Kazakhstan, there is a region the size of Italy where the soil carries a hidden curse. From 1949 to 1989, the Soviet Union detonated nearly 500 nuclear devices at the Semipalatinsk test site, 116 of them above ground. The last explosion happened on October 19, 1989, and the site was officially closed on August 29, 1991, 7/12. But closing a test site does not erase what was left behind. What remains is a top layer of Earth, just 0 to 8 centimeters deep, packed with plutonium, strontium, and cesium that refuse to stay put 2-4. And the wind is their carrier. Here is the problem that most people never consider. The radioactive material did not just sink deep into the Earth. Instead, the extreme heat of the explosions melted the topsoil, fusing the radionuclides to the surface layer like a radioactive crust 2-4. This means that the poison is not buried safely underground. It is sitting right on top, waiting for the right gust of wind to lift it into the air. And when that wind comes, it does not carry clean dust. It carries particles that are still lethal decades later. Not all dust travels the same way. The size of the particle determines its journey. Larger particles, about 0.05 to 0.1 millimeters, fall back to Earth within a few kilometers of where they started. But the really dangerous ones are tiny, 0.005 to 0.01 millimeters, smaller than the width of a human hair. Those particles can ride the wind for hundreds, even thousands of kilometers 2-4. Prevailing winds from the west and northwest carried these radioactive clouds across the border into Russia's Altai Region 12. The wind does not care about borders. It just moves. To understand how serious this is, consider what happens during a dust storm in the Djelan area, a section of the test site where underground and above-ground tests were concentrated. According to research from the Institute of Radiation Safety and Ecology in Kazakhstan, when thin dust is lifted from the ground, the concentration of strontium-90 in the air increases up to 5 times. For plutonium-239 and plutonium-240, the jump is far worse, 100 to 250 times higher than normal 4-6. That is not a minor fluctuation. That is a spike that turns breathing into a gamble. Now, here is the part that makes this a farmland nightmare. The total area affected by radioactive fallout from the Semipalatinsk site spans approximately 304,000 square kilometers, an area larger than the entire country of Italy 312. That land covers 3 regions of Kazakhstan: East Kazakhstan, Pavlodar, and Karaganda 12. But wind erosion does not stop at the old test site boundary. The contamination is constantly being resuspended and redistributed across agricultural land and pastures, years and decades after the last test. This windborne dust does not just hang in the air. It lands on grass and grains. It settles on the leaves of crops and on the surface of soil where cattle graze. From there, the radionuclides enter the food chain. Animals ingest contaminated plants. The radionuclides accumulate in their milk and meat. Then humans consume those products, and the radioactive particles make their way into human bodies 15. It is a slow, invisible pathway from the test site to the dinner table, a journey that can take years, but always arrives. There is another direct route: inhalation. In the early years after the site's closure, the government stopped guarding the perimeter. People began entering the zone to scavenge scrap metal, often without realizing the danger. They stirred up contaminated soil with their boots and their digging tools. When they breathed in the dust, they inhaled radioactive particles, some smaller than 10 microns, which lodge deep in the lungs and deliver a concentrated dose of radiation 15. The tests had stopped, but the poison was still claiming victims. The official numbers are staggering. More than 1.5 million people are officially recognized as having been negatively affected by these nuclear tests, 111. Over 700,000 individuals received radiation passports from the government, documents that entitled them to compensation and healthcare one. But the compensation was minimal. Between 2003 and 2017, about $30 million was paid out to more than 700,000 people. That comes to roughly $40 per person per year one. A sum that does not even cover a single doctor's visit. Health problems linked to the fallout are widespread and devastating. Survivors and their descendants report high rates of cancer, cardiovascular disease, digestive disorders, respiratory illnesses, and birth defects 115. Families living in villages downwind of the test site, like Janasemi, have passed these health burdens from one generation to the next. Parents born during the testing years now care for children with disabilities, while also watching their own parents suffer from conditions they believe were caused by the same radioactive dust one. But let us step back and ask the critical question. Why does the wind keep moving this contamination, even after the site has been closed for more than 30 years? The answer lies in the soil chemistry. The radionuclides are not chemically locked deep underground. They are concentrated in the uppermost layer of soil, and they attach to fine clay and silt particles that are easily lifted by even moderate winds for. Unlike heavy metals that sink, these particles stay on the surface, ready to be picked up. The wind is not creating new radiation, it is recycling the old. Scientists have proposed solutions. One approach uses interpolymer complexes, essentially, a type of liquid binder that can be sprayed onto the soil. When applied, these polymers form a cobweb-like crust that glues soil particles together. In laboratory tests, this treatment reduced wind erosion from 74% to less than 1% at a wind speed of 5 meters per second for 6. The treated soil also trapped 4 times more radioactive strontium than untreated soil for. It is a clever fix, but applying it to 300,000 square kilometers is an enormous challenge. Yet even with these technologies, the fundamental problem remains. The dust will keep moving as long as the topsoil is contaminated and the wind keeps blowing. In the summer months, when the steppe dries out and the winds pick up, the process accelerates. With less rainfall to bind the particles and stronger gusts to lift them, the secondary transfer of radionuclides becomes a seasonal cycle of recontamination 12. The farmland adjacent to the test site is not just polluted once, it is polluted again and again, every time the wind shifts direction. The wind rows of this region, the pattern of prevailing winds, has been documented for decades. Most of the year, air masses arrive from the west, northwest, and north 12. These are the same directions that carried radioactive clouds during the testing era and continue to carry contaminated dust today. The footprint of the test site is not static. It is a moving target, extending hundreds of kilometers in the direction of the wind. That is why farmland that never saw a single explosion can still fail to produce safe food. This region is not empty by accident. It was emptied by a force that does not appear on any map of visible contamination, by the physics of wind and the chemistry of radioactive decay. The winds of Semipalatinsk do not just carry dust. They carry the unresolved legacy of 4 decades of testing, scattered across the soil where people still try to grow food and raise cattle. And as long as that top layer of soil remains contaminated, the wind will turn farmland into radioactive dust. This is not a past disaster. It is a present, ongoing process. This region is a geological filter that rejects agriculture, not because the land is barren, but because the wind remembers what the ground has buried. First, it was a test site. Then it became a wasteland. But the wind never forgets, and neither does the soil. That is the hidden reason this region refuses to hold life.